Hello everyone, welcome back from Thanksgiving break. Hope you all had good break but did not forget everything. That tends to happen. We have a new topic for you today. It's called converting measurements. Hope you've printed the notes and everything else that goes with this, and you pause and rewind and keep up with this video and take good notes that you can use for a quiz or a test. Okay, as we're kind of heading down towards final exams and Christmas break and halfway through the year. So let's really finish this 6 weeks out strong. Let's start with our warm-up. It says, write both types of ratios. Remember, there are two types of ratios. Either you can write it like a fraction or with a colon. Those are the two types. Using this picture here. Number one says, what is the ratio of shaded squares to unshaded squares? So we're comparing shaded versus unshaded. Counting the shaded, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 shaded, and then all of the white squares would be the unshaded. So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. The ratio of shaded to unshaded is 10 to 15. That's how we read the colon. And then to write it the other way, as a normal fraction, that would be just 10 over 15. Of course, you can simplify this, and you should when it's a fraction, but let's just leave it that way and move on to number two. What is the ratio of shaded squares to total squares? So notice the difference. This time we're comparing shaded versus total number. The total number is 5 times 5, so that's going to be 25 total. And shaded, we already figured out there were 10 shaded, so it's going to be 10 to 25 is the comparison or ratio of shaded to total. And then as the other type of ratio, the fraction, it's going to be 10 over 25. So I hope you notice this is a good practice, because a lot of times in questions about writing a ratio, they'll throw in the word, sometimes you're comparing two different things, or sometimes you're comparing it to the total, and you need to figure out the total first and have to possibly tweak your numbers. So good little warm-up to remind you what we did before Thanksgiving break. All right, well, our new topic today of converting measurements, I'll introduce it to you in this sort of story situation. It's a very nice bedroom. Actually, I wish this was my bedroom, but all right. It says Maggie wants to put new wallpaper on her bedroom wall. So this one with the leaves, I'm guessing. Her wall measures 12 feet by 14 feet. That's the dimensions of the wall, so that it's 12 feet across maybe, and then 14 feet tall. That's what we mean when we use those measurements. However, at the store, the wallpaper is sold in inches. She doesn't know what to do. All right, so I'm kind of leaving this up to you. Can you pause and figure out what the problem is in this situation? She has measured her wall using a tape measure or whatever, and she has figured out that it is 12 feet by 14 feet. And so she kept those numbers in mind and went to the store, but in the store the wallpaper is being sold in inches, so it doesn't quite match with the feet that she measured. So what do we do? Anyone got the idea? We need to convert, of course. We need to change these feet, the feet, change them to inches so that we have matching measurements. So it's an apples to apples measurement, not an apples to oranges kind of thing. And then she can get the accurate number of wallpaper in inches that she actually needs for her bedroom. So that is the solution to this problem. Converting the units, converting the feet to inches. And that is our topic. As you can see, converting measurements is what we're going to do. we are going to be using something you already know, that you've already learned. We're going to be using it here to do this conversion. So to convert measurements, you will need, number one, this star reference materials chart, this conversion chart that has been put in the module for you to print out. It is also, you know, on the STAR test, you always get this in your booklet. It's one of those first few pages. You should always have it. We are going to be referring to this a lot. So to convert measurements, we need the chart first, and the second thing is we need to know how to set up and solve proportions, and this you actually know how to do. We're just going to figure out how these two things are linked together. But you already know, you all have been good at setting up and solving proportions. The chart is really the only thing that's new here. So let's jump right in. Start with a few basic rules. A lot of these should sound familiar to you, and then we'll get to examples. Before we even get to our rules, it says here, there's a phrase last time that I taught you guys to remember. It's like a shortcut little hint. When given blank numbers and the fourth is missing, use, does anyone remember what this was, the saying said? It was when given three numbers in a word problem or situation, whatever. When given three numbers and the fourth number is missing, use proportions. That is the go-to situation for using proportions. And we're going to be applying this rule again in this topic too. Now we get to our rules about proportions. So we set up proportions and we have to label the units. A lot of these should be sounding familiar to you from old notes because it's really all the same thing. Number 2 says same units must be across from each other. This will make more sense when we do some examples. And then last, simplify if possible, then use blank to solve. Who remembers how we solved, and I'm just throwing out an example here, proportions, that method of cross multiplication and division. Technically it's called cross multiplication and division, but we have been calling it bat and ball or the butterfly method, just to kind of use a more common term. Or you can also use a shortcut. Remember, see if you can find a relationship first. In this case, it was not obvious with those random numbers that I just threw out there. But this should all be familiar stuff. These are our rules. You can always refer back to these. And besides these rules, I'm going to give you one new major hint, shortcut. Really pay attention to this part of your notes. Okay, it's going to make life easier later, especially when we're doing word problems, which are always tricky. So this says, if you spot a measurement such as, go ahead and highlight or circle this whole phrase in parentheses here. If you spot a measurement such as, you know, this one, 1 feet equals 12 inches. If you spot this in a word problem, then you immediately write that as your first fraction. The other number can be placed after or later. Okay, so if you see one of these in a word problem, immediately just pull that out and write that as a fraction, like this, 1 foot over 12 inches. And then what that means is it's easier to finish off the rest of the proportion, setting up the rest. You'll pick out that other number that's in the problem and you'll just figure out if that goes on the top or the bottom. So this is a big hint. It's really going to make life easy, and I'll show you how this works in an example that we do. It's just that whenever you see one of these, immediately pull it out and write that as a fraction. Okay, so let's do examples. Let's see how this works. Number 1. Houston and Dallas are separated by 464 kilometers. There are approximately 8 kilometers in 4 miles. How many miles apart are the two cities? On a map, and you don't have this picture in your notes, but you're watching. So on a map here, Houston and Dallas are 464 kilometers apart. Then they've given us a separate a relationship, a comparison between kilometers and miles. We're going to take that. There are 8 kilometers in 4 miles. And that's going to be our first fraction. This is the relationship between kilometers and miles. 8 kilometers and 4 miles. Now we just need to figure out, since we know we're going to be using proportions, where does the 464 kilometers go? Does it go on the top? Does it go on the bottom? Same old question we've been asking ourselves in this whole topic. 464 kilometers, you're right, exactly. It goes on the top because it needs to match up with the other kilometers, meaning that our missing number, miles, is at the bottom. And all of this should look familiar now. This should look super familiar. We've done this before. Actually, first, why don't we simplify? That becomes 4 over 1. And then we can do bat and ball. 464 times 1 is 464, divided by 4 to get our answer. 1, then 6, 1, 4, 8. So I suppose that's 118 miles as our answer. So notice how not much was different. The same concepts of how to set up a proportion, all of that was the same, and the solving part is the same. It's just a different kind of word problem, and don't get thrown off by that. It's as simple as this. Okay, so let's try. Let's get it. This, I would say, is maybe easy. An easy example. There will be a question like this on a quiz that's coming up. Let's go to a medium example. Jeffrey and Mason are both painting a wooden fence. Jeffrey paints 3.5 feet of fence. Mason paints 12 feet of fence. So two people, they've painted different amounts. How many more inches did Jeffrey paint than Mason? Okay, so here's the situation. Jeffrey, I will do J for Jeffrey. Jeffrey has painted 13.5 feet. Mason has painted 12 feet. Clearly, Jeffrey has painted more. That's true. But that's not the question, is it? The question is how many more inches did Jeffrey paint? We know that he painted more in feet, but their question is how many more inches? So what we first need to do is change both of theirs to inches, and then we can figure out how many more. And how do we do how many more? Well, that's a subtraction. So this one is a little trickier because of the 2 steps. There's that extra step. Let's do our conversion part. We'll work on them one at a time. Oh, and look at what we've got here. We have a hint. 1 inch equals 12, 1 foot equals 12 inches. Remember what I told you to do? Whenever you see one of these parentheses with a measurement conversion, immediately put that into a fraction. 1 foot is the same or equivalent to 12 inches. So that's written in one fraction. And then our second fraction, now we just take Jeffrey's 13.5 feet, and we know that that belongs at the top along with the other feet. And that lets us solve very easily. That's going to be Jeffrey's part of the problem. We do the same thing for Mason. 1 foot over 12 inches. And so we know that 12 feet needs to go on the top. The conversion for inches will be on the bottom. Okay, let's solve. Mason's is easier. We can do this one first. Well, we see a pattern times 12. So we can also do times 12. So Mason has painted, 12 times 12 is 144 inches. So this is Mason. We got his number in inches because it's easier. Let's tackle Jeffrey's and not avoid it. I would say obviously, well, the pattern is times 13.5, and we would have to do the same to the bottom. I just need to create some room for myself. Let's do it over here. 12 times 13.5. Why don't y'all pause and calculate that for me? All right, that is 162. Okay, I worked it out. I didn't have much room, so I worked it out separately. 162 inches. We've got the conversions. Jeffrey, in inches, he painted 162. Mason painted 144. From here, we can do that second step, which was they actually wanted to know how many more inches did Jeffrey paint than Mason. The last step is just subtraction. 162 minus 144 to figure out that difference between the two. 18. Jeffrey painted 18 more inches than Mason. That is our final answer. I'm going to give you all a hint that you should probably put a star next to this example. There is a question on your quiz similar to this, a two-step question where you're going to have to first convert and then subtract, and you'll know, when you see that on a quiz. So I'm trying to give you examples when we do them in class together of something that prepares you for a quiz. All right, I have one more that we're going to do together, and then an exit ticket for you to see how well you've learned all of this all on your own. Okay, example number 3. I would say this one, moving on, we've done an easy, medium. I would say this one may be a hard, level 3, just because there's a little more to it, but let's tackle it together. Okay, Eli needs to drink 10 cups of water each day. So 10 glasses of these, 10 of those. He buys a pack of 16-ounce water bottles, right? And this is what we all do. I do this too. I just buy a pack of water bottles. It's easier it kind of forces me to drink water all day. If 1 cup equals 8 ounces, and notice, here's a measurement. They've given us one of these. I've told you specifically what to do with that. So keep that in mind. If 1 cup equals 8 ounces, how many ounces of water must he drink to meet his goal? Remember, his goal is up here. 10 cups of water is his goal. But this pack of water bottles is always in ounces. These bottles are in ounces. So first, there's actually 2 questions here. How many ounces of water must he drink to meet his goal? And then it says, how many water bottles does he have to drink each day? We'll tackle the first one. Again, if you're stuck and there's just a lot going on, and you're figuring out, okay, there's a cup, there's bottles, there's ounces, where do I even start? This is why I gave y'all that hint. Take that and immediately, a good starting place is always to do this as a fraction. 1 cup is related to 8 ounces. Okay, and that's your first fraction. From here, we need to figure out, we need to take the other number that we're working with, the 10 cups. That's how many cups he needs to drink, right? That's his goal. And so we put that as part of the second fraction. Obviously, cups should match with the other cups and go on the top. Our unknown number is at the bottom, but this one is relatively straightforward. Oops. Don't know what's going wrong with my pen here. Where we have a obvious shortcut. All right, it's times 10 and times 10. So Jeffrey, to meet his goal of 10 cups, that would be the equivalent of drinking 80 ounces. And so this does answer the first part of the question. How many ounces of water must he drink to meet his goal? He needs to drink 80 ounces of water to meet his goal. We've answered it. The second is kind of just more of a fun follow-up question. The second question says, so how many water bottles does he have to drink? Well, if this is how much, 80 ounces, how many water bottles basically is that? Each water bottle, remember, is 16 ounces. So how many of those equal 80? Well, that's a quick division. 80 divided by 16 to get our answer. 16 times 5 is exactly 80. So Jeffrey needs to drink 5 bottles worth. 5 bottles would be the same as drinking 80 ounces, which is the same as the 10 cups. So there was a lot to that. I would say the second part of the bottles maybe not so important. More important was that first step, which was setting up and converting and getting 80 ounces. Okay, so yes, these are a little different measurements and so on, but honestly, don't get caught up too much in that. Use this hint of immediately taking those measurements and making a fraction, and then from there you just build normal proportions and solve using bat and ball or a shortcut. Okay, so here's your exit ticket to wrap it all up. I would pause and try this all by yourself. When you get your answer, then hit play and compare it with what I do. Okay. The recommended dose for an adult taking cough syrup is 2 teaspoons. So you see that here. They always give the dosage on the back. So for an adult, they should fill this cap halfway up. That would be 2 teaspoons, and that would be the correct amount to take. If 1 teaspoon equals 5 milliliters, and yes, you notice they have clearly given us a measurement here. You know what to do with that. If 1 teaspoon equals 5 milliliters, how many milliliters is the recommended dose for an adult? So what they're asking us is the recommended dose is 2 teaspoons, but what is that in milliliters though? So we first immediately pull out that measurement. 1 teaspoon. We abbreviate that as TSP, and we write this as a fraction. 1 teaspoon equals 5 milliliters. That's our first fraction. From here, we just build on top of that. Where is the other number? 2 teaspoons. Where does that go? On the top, of course. Leaving our missing number. We're trying to convert to milliliters at the bottom. Easy shortcut. Times 2. Times 2. Which is 10 milliliters. That's your answer. We've converted the recommended dose of 2 teaspoons. We've converted this to milliliters like they've asked. And that's how you do converting units, converting measurements. A lot of times the word problem itself is going to have the conversion for you, but it's always good to have that star chart on hand, this one. You need to know how to set up proportions, of course, and I would especially use this shortcut that I've taught you right here. Okay, so make sure your notes are complete, stick them into your composition notebook, and good luck. Bye-bye.